Hello? Yep. Morning, everyone. Just quick note, if you can move a bit towards the wall, whichever wall is closer to you, so we can get latecomers coming in and finding the seats. If you can do that, it would be great. Thank you. And I'm welcoming you to the Building a Zero Downtime with Kate's cluster. And I would like to welcome on stage Feilong and Andrew from Catalyst Cloud. Give them a big round of applause.
Thank you. You go first. Okay. So we're here to talk about what we had to do to get zero downtime with Kubernetes in a public cloud situation. So there's a kind of a rundown about where we're going to head to and what we're going to cover during this session. You go first.
Hello, everyone. I'm Feilong Wang. I'm the head of R&D at Catalyst Cloud, and I'm a long-term open source contributor. Now I'm the co-contributor for OpenStack Docker, the messaging service, and I'm also the project team lead for OpenStack Magnum. Magnum is kind of the container orchestration engine service for OpenStack, and I'm also a Kubernetes contributor as well.
So I thought I'd just do a quick introduction about what Catalyst Cloud is. So we're a New Zealand-based cloud provider. We do both public cloud and private cloud deployments. I kind of started working on the cloud side of things for us back around 2012 when it started out as a Skunksworks project. We were just quietly working away internally without really telling people what we were doing. And the idea was that we were going to use it as an internal service because we realized we've got, at that stage, 1,200 VMs that we had to manage somehow. And honestly, manually managing KVM was not really scaling. So the original plan was it was going to be an internal project. We looked at all the different cloud software around, decided that OpenStack was the one that seemed to have the best future. Lots of people working on it. So we started working on that. Some of our customers got wind of what we were doing, and they said, actually, can we buy that too? So that's when we pivoted and became a public cloud provider. We went live in March 2014, and we started with one region down in the bottom there, and we've expanded to 3 regions around New Zealand. And the reason that people cared about this kind of stuff is the other public cloud providers are over there. That's a 4,000-kilometer round trip. That really kills latency when you're doing interactive websites or applications of any sort, and it costs a bit of money to get traffic across that ditch. So we had a lot of people in New Zealand who were really keen to use a cloud. They wanted a real cloud where there was an API that they could use, whereas some of the other people in the market, there were no APIs. You called people up, you sent them emails, and then they'd build you a VM and give you access to it. That's not how we do things, right? So that's kind of where we are. That's what we've done. So why are we interested in Kubernetes? So obviously cloud, we started with infrastructure as a service. We always knew that we're going to need to have platform as a service because that's obviously where things were going. That's where things are at. Again, we looked around a bunch of the things. Kubernetes was the best fit for what we wanted to do. It seemed like quite a sensible thing. But there were some gaps. There were some things that didn't do for us to be comfortable to put Magnum out as a production-ready container as a service offering. And so that's where Feilong and his team stepped up and they fixed those issues for us. And it took about quite a bit of effort, and that's what he's going to talk about. So I'll hand over now. Oh, and we're the first, and I believe still only, Kubernetes certified service provider in New Zealand, which was pretty cool. That took quite a bit of effort to get over the line, and we're pretty proud of that.
Cool. So as for zero downtime, as you can see from the title, actually I just delivered another topic last year at Christchurch LCA about the production-ready Kubernetes journey, because it is a long journey when we are involved in Kubernetes to deliver a Kubernetes service on our cloud. It's a long journey, and all the work we have done is open source. So there's no, things under the hood we don't want to share, because I have joined quite a lot of conference, and there are some sessions just say we are doing great things and we can do this, this, and this, but we won't tell you the details. And you just know we are doing good things, but you don't know how we have done that. But for us, all the work we are doing is open sourced, and you can get from GitHub. Yeah. So when I say zero downtime in Kubernetes context, that's probably the most difficult part when we working on the Kubernetes service to deliver on our public cloud, because it's quite difficult. So when we say there are zero downtime in Kubernetes context, there are two levels actually. The first level is the user application. So actually we want to get zero downtime for user application. And another level is the end of the level is the Kubernetes cluster. But the ultimate goal is zero downtime for users' application. So that's the context. And when we say zero downtime for user application, actually Kubernetes has done, probably most of the magic under the hood. And you just need to use a controller, probably like deployment, to manage your application. And there's just some very, very little tricks you probably need to keep in mind. The first one is you need to make sure when you use a controller like deployment, make sure you have the replicas more than 2, probably 3 or more, depends on your requirements. And the second one is using the pod disruption budget with the mean available. So that one can help you. So when you do a rolling upgrade for your Kubernetes cluster, say when you want to upgrade Kubernetes cluster from version v1.14.3 to v1.15.6. So with that one, you can make sure there is at least one pod is still available to serve the request from your customer. This one is quite important. And another one is setting the correct rolling update strategy. And actually, there are some other things you also need to pay attention for your application is the connection draining. Because when you do maintenance or rolling update for your user application, you want to drain the connection. You don't want to, any new request on that pod. So for that case, you need to make sure you use the readiness probe and handle the SIG terminal signal correctly. And another thing is the HTTP keep alive. But I won't cover the details for my talk, because generally you can get a lot of information from website, from internet about how to achieve a zero downtime for user application. I just want to share some YAML piece about what I just mentioned in this page. The first one is when you're using the deployment controller, make sure the replicas more than 2 or 3 or more. And another one is pod disruption budget. And you need to make sure the mean available is 1 or 2, just depends on your requirements. And when we say connection draining, another thing probably same is gracefully shutting down your pods, because not all the user application can handle the SIG term correctly. So for example, if you're using like Nginx doesn't respect the SIG term. So you have to do something like this to use the pre-stop in your YAML. And The last thing is a rolling update strategy. If you want to rolling update your application to upgrade from probably version 1 to version 2, you can set this to the max surge and the max unavailable. That means the max unavailable port from my application is 0. So make sure when you Kubernetes doing the rolling upgrade, make sure there is at least one port can still serving requests from outside. So that's the first layer. I just want to give a brief introduction because Kubernetes has done most of the things under the hood. We don't have to worry about that layer. Just give it a correct, proper YAML file for your application, for your service. You can probably good at that level. But another level is the Kubernetes cluster. If you are using probably homemade Kubernetes cluster or even the EKS or AKS, you still need to worry about the downtime for the Kubernetes cluster because as far as I know, so far only GKE, the Google Kubernetes engine can support auto repair. So that's the key part. I want to introduce the work we are doing, that's Autohealing. So when we say zero downtime for Kubernetes cluster, there are two scenarios, typical scenarios we want to cover. The first one is the planned maintenance. For example, when we say planned maintenance, like the upgrade, for example, I want to upgrade Kubernetes from v1.14 to v1.15. This is a planned maintenance. So for that case, to achieve zero downtime for your Kubernetes cluster is quite simple. I will show you later. And another scenario is the unexpected node broken. It can happen anytime, any day. So for example, your kubelet could be in not ready status, not condition for whatever network problem or other problem, or your etcd cluster or at least one of the member of your etcd cluster just down, or your Kubernetes API server, one of the Kubernetes API server is down. So for that kind of scenarios, we would like to see how to achieve the zero downtime for that case. So for the planned maintenance to get the zero downtime for your application for the Kubernetes cluster is quite simple. So you just need to follow the typical process. For example, if I just want to do a rolling upgrade for my Kubernetes cluster to upgrade the version from probably A version to B version, the general process is the first step is codon. Codon is a command in Kubernetes. So I want to codon the worker node 1. That means there's no request, new pod workload can be scheduled on that worker node because I want to maintain it, I want to rolling upgrade on that node to do the version upgrade. And the second step is dream. Dream means I want to reschedule all the workload currently running on that worker node to any other worker nodes so that I can do maintenance on that node. So the third step is just do whatever you want to do for that worker node. Say upgrade the version. For example, if you're using a container-based deployment for your Kubernetes cluster, you just need to stop the current container, download a new container, and start it, and done. You just got a new version of your Kubernetes. And the last step is uncodon, means I'm done. You can just schedule new workload on this worker node. So you just need to do this step one by one for your each worker nodes. So you won't get downtime if you have done a proper preparation, as I mentioned, for your user application. There is no downtime. So as you can see, for planned maintenance, to get zero downtime is quite simple. You just need to follow a standard process. But how can we do for the unexpected node broken? Actually, when we start the journey to start looking at this problem, GKE has a good example. In GKE, you just need to enable auto repair. In GKE, it's named auto repair. So it means if there is worker nodes down, GKE just replace with a new one. But GKE is not open source, so we don't know how GKE do that. So we have to innovate to create something new to achieve the same goal. So there are some things when we start the journey we think about. The first one is the failure detection. Because when we say we would like to get zero downtime when there is an unexpected node broken, we would like to detect the failure first. We need to make sure there is a real failure, not just a jitter for your network. So that's the first problem. And the second one is repair and healing. And for that case, we would like to, because when we do this work, our background is OpenStack Magnum. So we need to make sure the new Autohealer we are working on can do properly, can integrate with OpenStack correctly. But we also want to open source edge and to support all the other cloud providers. So technically, we would like to get the repair and healing pluggable to support different cloud providers. And the third thing we think about is manual or auto. Actually, there is just one answer. We want to each auto, just auto heal. All the failures can be detected during the journey. So it's auto healing. So it's introduced the final topic actually we want to discuss in this session is auto healing. We want to get a service or a component in the Kubernetes cluster can do auto healing for the cluster. So it's quite hard. It's like replace the engine when the airplane is flying. So we need to make sure there is no other impact for the Kubernetes cluster. Because when we say node broken, generally it's not a totally broken. The Kubernetes cluster could be still running, but just part of the cluster is down. For example, I say probably one of the worker nodes is down, or one of the master is down, not totally broken. If it's totally broken, I don't think there's a good solution for that. So the second question we think about is how to detect the failure. So there's two sides we think about. The first one is detect the failure from outside. Outside means we have a control plane. So just like you have GKE or you have AKS, that is outside, that is control plane for the Kubernetes cluster. The control plane can send a request for your Kubernetes cluster to get your worker nodes conditions or the API to get a general health status for your Kubernetes cluster to understand if it's healthy or not. Or we can just run a controller, a small app inside the Kubernetes cluster to understand better if the Kubernetes cluster is still healthy or not. So finally, we just go for the second one. We created an auto healer running inside the Kubernetes cluster because we do have some special requirement. So nowadays, when you create a cluster, probably on different cloud providers, there is an option named like probably private cluster or fully isolated. That means the cluster, the Kubernetes cluster is fully private. And that means as a cloud provider, for example, for OpenStack case, OpenStack Magnum can't talk to a private cluster because the cluster is totally isolated from internet, even from the control plane. So for that case, the only way we can reach the cluster is running something inside the cluster to detect the failure and report the status back to the control plane. So it's from one side to another side. And another thing is how to make sure the failure is not a jitter, it's a real failure. So we just use a wait time. That means how long, for example, if we just found a node condition is not ready, we want to wait 10 minutes or 5 minutes to make sure it's really broken or just, not a jitter. And another thing we think about is we would like to get a pluggable, to get a plug-in mechanism for the failure, for the different failure. And another thing I just mentioned is support different cloud providers. Even though currently we only support OpenStack Magnum, but actually you can easily to add a driver for EKS or AKS. So this is a typical Kubernetes deployment. You may have 3 master nodes, and on each master node you have Kubernetes API and probably etcd member. And you probably have 3 worker nodes, and on worker nodes you probably only have kubelet and kubeproxy. So for Autohealing, we have done quite a lot research for that case, because we would like to get the solution open sourced. So we just searched to see if there is an existing open source solution. The first one we got is this combination with Drino plus cluster autoscaler. Drino is a very, very small controller app. You can run it in your Kubernetes cluster. It's quite simple. And when you want to support different failures or more failures for your worker nodes, you can to extend NPD, node problem detector, to detect different failures. It doesn't support. And but there is a problem. The problem is with autoscaler, the node count is unpredictable after repairing, because we are leveraging autoscaler to replace the broken node. And another problem is this combination only supports worker nodes failure. And there is no leader election. So I will explain how it works. So how Drino plus cluster autoscaler works. So Drino can be used to detect the failure of your worker nodes. It will periodically send a request for all the worker nodes to get the node condition, because there is some built-in node condition for Kubernetes. So you can set some conditions you expect. For example, you can set node condition in not ready in 10 minutes. After 10 minutes, that means if the worker node in not ready node condition more than 10 minutes, that worker node is a broken worker node. So then Drino will drain the worker node to remove all the workloads from that worker node, to drain all the workload from that worker. And then autoscaler because Autoscaler also running on the Kubernetes cluster, it will periodically check the workload for each worker node, and it will see, okay, currently there is an empty worker node because the default workload threshold is 50%. Because you have removed all the worker, you can drain the worker node, so currently there is no workload on that node. So currently, it will definitely under 50%. You can adjust that parameter value, but let's say the 50%. If it's under 50%, Autoscaler will just remove that worker node. But the problem is, with that case, you can't predict the final worker nodes numbers. For example, initially you have 3 worker nodes, and currently worker 1 is done, and Drino just detect the failure and drain the worker node. Then Autoscaler just remove that node. But if at that moment, Autoscaler think, okay, with the left 2 worker node, I can still support the current workload, so I don't have to, get the worker node back. I just keep 2 worker nodes. That makes sense, but it doesn't really fit our requirement because on our case, we really want to get the node back. Say, if initially I have 3 worker nodes, then after the repair, after the auto-healing, I still want to get 3 worker nodes. But with this combination, Drino plus CA, it doesn't meet our requirements. But we still support it in upstream, in OpenStack Magnum. In OpenStack Magnum, when you want to enable auto-healing feature, you can select the Drino combination, Drino plus cluster Autoscaler. And as I mentioned, it's fully open source. You can find all the links from there. Drino from Planet Labs and the cluster Autoscaler is from Kubernetes, the Kubernetes repo. So then we just think we probably need an auto-healer, just do one thing and do it well. So we just create Magnum auto-healer. We just want to run in a Kubernetes cluster, and it can detect the failure from master for etcd for Kubernetes API server as well. And sorry, this one, you can just skip this line. For that case, with Magnum Autohealer, the node count is predictable because no matter how, I can just change it. Yeah, because I just copy the about page. So with Magnum Autohealer, if you initially have 3 worker nodes, after the repairing, you can still have 3. That's one of the requirements from our company. So that's one of the reasons we created it. It's also open sourced, but currently is under Kubernetes cloud provider OpenStack because at this moment, it only support OpenStack as the cloud provider. But as I mentioned, you can easily extend it to support EKS or AKS. You don't need it for GKE because GKE has the auto repair. I can give you some example. For example, if you want to support EKS in AWS, because AWS already got a driver for Autoscaler, so you can easily copy, paste some code from Autoscaler, the EKS driver, to finish the repairing part. because the design of Magnum Autohealer is the Autohealer will do all the failure detection work. And as for the failure, the repairing, the repair and the healer part, that depends on how the cloud provider implement. So it will, I can just give you some details here. So at this moment, if you have a Kubernetes cluster with, for example, 3 master nodes, you can see at here, you may have 3 Magnum Autohealer pods. And Magnum Autohealer pods, Autohealer does support the leader election. So at one time, only 1 leader is running. And here is the config file, a part of the config file of Magnum Autohealer. As you can see, this is the monitor interval. So that means it will run the detect every 15 minutes. You can change it. And this is a very interesting config option, the check delay after add. So we add this because we would like the Autohealer can work with Autoscaler. It's quite tricky when you run it on production. For example, when you just, I will give you the example later because it's quite complicated. So the other thing is the leader elect. We can enable it to true. The next part is a health check. So when we say health check, there is 2 different tabs. The first one is master. The second one is worker. For master, you can use different tabs as well. So the first is the endpoint. So it can just talk to an endpoint you predefined. For example, it can just talk to the health day API of Kubernetes API to check if it always can return 200 HTTP code. If it doesn't, and its duration is 60 seconds, Autohealer will think, okay, probably the API server is down. Then it will trigger a repair process to repair the master node. And the repair is quite simple. Just delete, create a new one, and then delete the old one. But still follow the process as mentioned for manual, for the planned maintenance. The first step is cordon and drain and replace, add a new one and just and cordon it. And for node condition, it also can support different tabs. For ready, for example, if it's in, it will check if the node condition in ready or not. If it's not in ready status and for 5 minutes, it will think the current worker node is down and then trigger a repair process. For worker nodes, node condition is same. So I will explain why the auto-scaling plus auto-healing and probably plus manual resizing is quite complicated because autoscaler can run anytime to shrink, to add or remove new nodes from your cluster. And auto-healing can also remove and add a new node in your cluster. And a user may also do a manual resizing for the cluster as well. So it can, you need to make sure they can work together correctly. Because recently, actually we are running the auto-healing on our production as a default configuration. But we didn't enable the auto-scaling as a default configuration. And one day I just got a ticket say, we just got a cluster. We manually resize the cluster from 2 nodes to 3 nodes. And after about 5 or 10 minutes, the new node just gone. We don't know why. Could you guys just investigate what happened? So the first question, I just asked the originator, the customer. So did you enable auto-scaling? Because it's quite like an auto-scaling case. He just said, no, we didn't enable auto-scaling. So he just feel not good because it could be very complicated and it's very hard to debug. So I just checked the configuration of his cluster. I just saw he just enabled the autoscaler. So that means if you want to just enable autoscaler with Autohealing, and you want even do manual resizing for your Kubernetes cluster, you need to make sure you manage the parameters for different service correctly. For example, if you're trying to manually resizing your Kubernetes cluster from 2 worker nodes to 3 worker nodes, then you have to change the minimum node count of autoscaler to 3. Otherwise, autoscaler may think, okay, your current Kubernetes cluster doesn't need 3. Your current workloads just need 1 or 2. I will just remove it. So yeah, it's quite complicated for that case, but it's possible. This parameter I just mentioned is, for example, if autoscaler, our user just manually add a new worker node, that means we won't check the status for new node if the new node just added in the last 20 minutes. I just skip it. I will look after that node later after 20 minutes. Otherwise, for example, if user or autoscaler just either manually or automatically add a new node within, say, 1 minute, the node could be still in not ready status. It needs to sync to initialize. And then for that case, Autohealer may think that's a broken node and just remove it. So you have to manage those parameters carefully. Yeah, I'm not sure if I have time for Autohealing demo. Okay. So as you can see from above, we just create a 3 master. This is the master count, and this is the node count, 3 master, 3 worker. And you can see all the 3, actually 6 virtual machines are in good status. And from the Kubernetes perspective, they are in ready status. And then we just SSH into one of the master nodes. This is the log. The Autohealer will periodically check the status for master nodes and the worker nodes. And as you can see, we just SSH into the meaning 1 and then stop the kubelet. And as you can see from the log, it just check, just found the meaning 1 is unhealthy. And from here, from the Kubernetes perspective with Q control, you can see is in not ready status. And Autohealer will shut off the worker node first. And there is a new one just created. And see here. Yeah, it's back right there. Yeah. So that's pretty much all the work. Yeah. That's all. Thank you.
Does anyone have any questions? Just raise your hand and I'll pass the mic. Thanks.
Sorry, in your demo, when you stop kubelet, how long did it take to recover? It's like 5 minutes, right? According to your settings.
It depends on your cloud provider, actually. And if, for example, if you're in your cloud, you may take like 2 minutes to start a new virtual machine. You just need to, adjust the parameter.
No, but in your case, because you had like this setting, 5 minutes.
It's quick. It's just, skip some time to make the demo quick. Yeah.
Yeah, could you talk a bit more about the like rate limiting or safeguards? Like what happens if the node where the healer is running goes wrong and the healer starts misunderstanding what's happening?
Because currently, as I mentioned, currently we are running the Autohealer on all the master nodes. So for that case, for example, if only, say you have 3 master nodes, if there is only 1 master node is down, you're okay because it's a leader election. If just the current leader running on master 1 and master 1 is down, then the other pod will elect a new leader and will detect the failure for the
and what about cases like a network split or a partition across your cluster itself? Like, are you going to, what would happen in that case? Will it start replacing half the cluster that is on the other side of the partition, or what? Like,
sorry?
Some terrible situation like a partition where you've lost network connectivity between one half of your cluster and the other half of your cluster, or like an availability zone?
For worker nodes or master nodes, or all?
Yeah, so I mean, imagine it's or something, you've got one edge. I'm just wondering what this would do. Like if I think you've built something which is great, but also if it goes off the rails, it's going to sit there and go replace as fast as it can go, from what I understand.
No, for at least for our case, it will replace the node one by one. For example, when you say you have 6 or 10 worker nodes and half of them, like say 5 worker nodes is down, then the Autohealer will try to repair them one by one. And when they repair one, it won't trigger another repair because it need to make sure the stack and the cluster is back to normal status and then repair another.
Right, cool. Thank you. That's what I was trying to tease out. Thank you.
I have the same question, but with partition, network partitioning is meant. That means the network has an outage, and what happens then? That was, I think, the question. It's not about node going down, no, it's about cap theorem. Yes. Your question, okay.
Anyone else?
Hi, Alex. So all those practices and experiences that you got with implementing Autohealing for your, I guess, primarily for your internal, to reduce your internal administrative load, since you're also selling this product as a service, are you able to also put that in some legal form to your clients and guarantee them some kind of availabilities, or can you tell them that you're able to recover the nodes in under some time?
Yeah,
and do you actually do that? And if they actually want that? Thank you.
Yeah. Actually, when we start the journey, we would like to build this Kubernetes service. one of the feature we would like is the auto-healing, because we think that's the good one, the important one, the critical one, can fill the gap. Because as I mentioned, Kubernetes itself has finished most of the magic to get your application zero downtime to serving for the request. But if your Kubernetes cluster itself just down, you can't get a zero downtime for your application, even though you have a fabulous Kubernetes. So that's the original goal why I would like to build the auto-healer. But as I mentioned, it's pluggable for the failure detecting and for the repairing. Both part are pluggable, so you can just extend it to support new failures, to support new cloud providers, and it's fully open sourced. If you think it's not perfect, just submit a PR to make it better.
Final question? We're done? No one? Well, let's have another round of applause for Feilong.
Thank you.
And Andrew?